This is my vibratory tumbler. It's a pretty good one. It's actually a beast. Um, I got it after my first one from Lyman died, and I spent a bit of money, and it's lasted me for years. It's still going strong and does a really, really good job. So given that, why am I getting into this project, creating another brass tumbler, um, uh, when I already have quite a good one that does the job? There are a couple of things that I may want to tumble other than brass. For example, I would like to try tumbling my knives to put satin finish on them. I've seen rock tumbling as well as some other media tumbling on the knife blades that produces quite nice finishes. And obviously this is not going to work. In addition, I would like to explore the idea of steel media tumbling, which requires hermetically sealed canisters and rotary tumblers, which I don't have. I could purchase one. They're not that expensive, but you know the philosophy. Why build something for $30 when you can build something for $300? Except in this case, I can actually build it for a lot cheaper than that, given that I do have most of the materials and parts that I'm going to need. So that's what I'm going to do. I'm going to build my own rotary tumbler, and let's see how this project goes. It is not at all uncommon for me to fly by the seat of my pants on these projects. However, in this case, I felt that I wanted to have something more than just a mental picture to work from. So I have modeled major elements in Google SketchUp. I have modeled the canister, which will be constructed from 4-inch PVC pipe with 3D printed end caps. I have modeled the rollers, which I have salvaged from the same treadmill that gave up its life to become a belt grinder, and the motor that I intend to use as well. Everything else here, plus possibly more components, will be fabbed as I start on my project. Now that I have my blueprint, I'm going to jump right in and start doing some fabrication. Now I have these plates, and they combine with these rollers. Roughly this way. Now the alignment is going to be pretty critical here. Just like in my 3D model, I've cut these two bars that start becoming a part of my frame. Sort of space everything out and align everything. Well, that's the basic idea. Of course, now I could pull out my welder and start tacking these things together, but first I need to figure out exactly how I'm going to tack things, because in my model I did not actually design this part, but there's going to be a motor here with a motor mount. The belt is going to be here. I need to be able to, get to the motor. I need to be able to get to the belt, switch it out. I can't really weld on both sides anyway, because there's no way I'll be able to get these rollers into the assembly. So the assembly will have to come apart, so it can't be welded all together. So what I'm thinking is that I weld this end over here, and I attach the plates to the frame with some sort of brackets held together with screws on this side, so I could always unscrew a couple of screws, remove this plate, work on this roller, and maybe undo a couple of screws over here and remove that as well. So that's the basic idea. Let me figure out exactly how I'm going to do that. I've aligned this about as perfect as I could. I've added a gusset here, and now it's time to start tacking this thing together. Now I'm going to do the other side. Speed is the enemy here. It's very important to make sure that everything is nice and square before tacking things together. Well, this is the first step. I don't want to handle it too much. I think I'll throw another 2 tacks here, and then we'll be good to go. Have this piece of 3/4 inch angle iron that I've marked up, and I'm going to drill it, tap it, then cut it up into individual brackets, and that's what's going to hold my frame together. have a basic frame with the roller assembly. Got my container for the tumbler, and everything seems to be working pretty much as expected so far. There is a problem, however, regardless of how hard I try to make sure that everything's aligned, everything is parallel and perpendicular, and so on and so forth. The container still drifts on the rollers, and depending on the direction in which you spin it, it will drift either to the left or to the right. And I've measured and remeasured, and really I have somewhere within a few tenths of a millimeter everything is properly aligned. So I could try to take this apart again and see if I can achieve a greater level of precision, but really my odds, aren't that great. I think this is about as perfect as I can make it. So to deal with this scenario, I did a very simple modification. I added this ball bearing here. So as the container drifts, and I'm going to make sure that the roller rotation are such that the container drifts to the right, it will eventually hit the ball bearing, and the ball bearing will stop it, and it will spin nicely, and everything will operate as it should. So far so good. Now I should probably start working on mounting the motor. This is the motor I'm going to use. It is a 12 volt, 550 RPM, high torque motor. There's actually some reduction gears in this section over here. Not sure how much of a high torque I need. Things spin fairly easily with a little effort, but it's a motor I have already. I actually got it from my robotic bartender project, but it ended up being too slow to operate the cup lifter. So it's been sitting around. Now I'm going to utilize it for this project. So I want to put this motor somewhere about here, roughly. Right. Oh, let me adjust the camera. Right. So this is where I would like to mount the motor, and then build a pulley, or I'm not sure what the proper technical term is for an attachment to the motor shaft, that I'm going to then run a belt from the motor to this roller, and it's probably going to be roughly a 2-to-1 reduction, so it's going to be somewhere about 275 RPM at max. I'll probably put in a speed controller as well to control it. I'm not sure if I need it, but better safe than sorry. And then that's going to be the thing that powers this device. And here's why you should never throw stuff away. I need to build a mount for this motor, and the biggest piece of angle iron I have is just a little small. It's almost there. If I don't drill the top mounting hole, but I need to mount this massive beast. Let's be serious, it could probably live just fine with just 2 mounting holes, but if they give me 6, I'm going to use all 6 just because. So yeah, so this is just a little small, and this is the biggest piece of angle iron I have. That's what I would normally use here. But in my scrap pile I have this, cut off from some project or other of mine. A failed one, obviously. And yeah, this one will work just fine. So that's what I'm going to use. I've cut the piece of flat bar that will act as a place where I'll anchor my mount. And having the mount, I've kind of positioned it, marked it, drilled and tapped the holes for the motor mount, and now I've positioned this whole assembly exactly where I need it to be in relation to the roller. These little clamps are awesome for this type of application. And now everything's clamped together. I'm just going to throw in a couple of quick tacks to hold it in place, and then I will assemble everything so it all fits together. For power, I'm using a rather simple arrangement for the moment. It's going to get a little bit more interesting at the end, but I have a simple LED transformer, 12 volts, 36 watts, which I think will be way more power than this tiny guy will ever take, wired into an outlet on one side, and then to the motor on the other side, and that's going to power the whole thing. I've used flexible measuring tape to measure the circumference around both of these pulleys when they're fully mounted, and then with a little bit of 3D modeling, I printed this belt in semi-flex material, and I'm going to assemble the whole thing and let's see how it runs. Well, it's a hair on the noisy side, however, it does work. I mean, theoretically, I could just leave it as this. It does exactly the job it needs to do. Of course, I'm going to put quite a few finishing touches on it. However, I've been running it now for probably an hour, which is probably about as much as I would normally run it. The motor is quite cool. Everything seems to be functioning as it should be. And this is the final product. As you can see, I've added a few enhancements. Obviously a touch of paint, which pretties things up. Legs for the frame to rest on. What you can see is a bit of half-inch angle iron under here to reinforce it, give more stiffness to the frame. This round bar here serves the same purpose. This is the control box. It's a simple combination of a timer I got off of Amazon, and I'll put that into the description, the link to it, as well as the power cable. This little box is something I designed and 3D printed, pretty straightforward. The timer, I think, was a really nice touch. I've always ended up forgetting my tumbler and leaving it running overnight, which probably had something to do with my first one dying as quickly as it did. I already covered the LED transformer, which is under here, and that's it. This is the assembled, finished, painted, and ready to go. The nice feature of this tumbler is that I can have multiple canisters for multiple purposes. For example, cleaning up 2 to 3 brass requires several different types of media to remove the lube after resizing the cases, and that you don't want to use for any other cleaning. As well as I can add different size canisters. There's nothing that prevents me from going up except the material and the ingenuity, and I'm sure I'll be creating some larger canisters that will work just as well on this arrangement. And in the future, as I mentioned before, I would like to explore the steel media tumbling, which requires hermetically sealed containers because it involves liquid in the process, which I will be exploring as well. For now, let's give this guy a whirl and see how it goes. I'm adding some crushed walnut media that I will use to clean my brass. About a little bit more than a third of the container, I think. About that there. There's good. And now I'm going to add some range brass, filthy 40 cal brass. Let's put that in. Again, I'm going to leave about a third, maybe or so, of the container empty, just to allow stuff to move around in there. And oh yeah, this funnel is something I also 3D printed. Makes it easier to put things into the container. Now let's put the end cap on it, and we're going to be ready to tumble. And in about 2 hours, we can come back and see the results. Let's see what we got. Well, these are pretty clean. I mean, I didn't use the cleanest of the media to tumble them, and I should probably refresh my media and maybe add a little bit of polish. But in general, they're clean both inside and out and ready to be reloaded. So this new tumbler definitely works, and it will make a nice addition to my tool bench.